In this lecture, we're going to look at how to find the direction of sunrise and sunset. Knowing the direction of sunrise and sunset can be a big help to a navigator, whether you're on land or at sea. You can use this information throughout about half of the morning and half of the afternoon to help guide you to your destination. To find the direction of sunrise and sunset, you need to know a few things. 1. You need to know the sun's maximum amplitude at your latitude. Of course, this means you also need to know your approximate latitude. 2. You need to know the date, or at least some reasonable approximation of the date. And 3. You need to have some idea about how fast the sun's amplitude changes throughout the season. From earlier lectures, you already know that the sun's amplitude is 0 on the equinox and reaches its maximum on the solstice, and that amplitude changes don't take place evenly throughout the season, but occur more rapidly around the equinoxes than they do around the solstices. With these ideas in mind, the following method can help you estimate the sun's amplitude on any given date at any given latitude. First, draw a line on a piece of paper. If you have no paper, draw your line in the dirt with a stick if you have to. It doesn't matter where, just draw a line. This line represents the season you're in. On the line's left end, write equinox, and on the line's right end, write solstice. For estimation purposes, consider that each season has 90 days. While that's not exactly true, it's a good round figure and plenty close enough for our rough navigation purposes. Our line is going to represent this 90-day period. Next, since there are 3 months in a season, and each month is more or less 30 days long, we'll divide our line into 3 sections, each of which will represent a 30-day period. But we won't divide our line into 3 equal sections, since our line is to be a graphic representation of amplitude changes as they occur throughout the season. As we know, amplitude changes occur faster near the equinox than they do near the solstice. So, how then do we divide our seasonal line into 30-day periods? Easy. We use the 50-35-15 rule. The 50-35-15 rule says that 30 days out from either equinox, the sun's amplitude will be at approximately 50% of its maximum for any given latitude. An additional 30 days out from either equinox, that is 60 days out, the sun's amplitude will be at 85%, which is an additional 35%, of its maximum for that latitude. Finally, after 90 days, on either solstice, the sun's amplitude is at its maximum for that latitude. The 50-35-15 rule isn't exact, but it's a field expedient way to estimate the current amplitude. And a decent estimate is all we need, especially considering that our navigation challenge is likely to be to find a broad catching feature no more than a few kilometers distant. I devised the 50-35-15 rule from the circular navigation chart used by the United States Marine Corps to find the sun's amplitude on any given latitude on any given day of the year. This chart is found in the United States Marine Corps' Summer Survival Course Handbook on page 7-5 in the chapter on survival navigation. The pages preceding the circle in that book tell you how to use the chart. The way I see it, you're not likely to have the circular navigation chart with you when you need it most, and it would be a tall challenge to produce it from memory, especially under the stressors of many field situations. The 50-35-15 rule, however, provides a close approximation of the results you'd get from the circular navigation chart, and it's easy enough to use without having to resort to anything other than what's in your head. So now let's apply the rule to our line. Working from the equinox to the solstice, find the halfway point in your line. Label this point 30 days. Then, continuing away from the equinox and toward the solstice, measure another 35% of the line's total length and make a mark there. Label this point 60 days. Finally, after an additional 15%, label the line's endpoint at the solstice 90 days. Next, label the equinox and the solstice with the dates encompassing the date in question. For instance, if you want to estimate the sun's amplitude on, say, February 11, label the equinox March 21st and the solstice December 21st because February 11 falls between those two dates. Will the equinoxes and solstices always fall on the 21st? No, but it's close enough. Next, label your line with the maximum amplitude value for your latitude. You need to carry this bit of data in your head. Don't go anywhere without knowing your approximate latitude and the sun's amplitude at that latitude. The amplitude values come from the table presented in prior lectures. We'll say we're at latitude 45 degrees north, where the sun's maximum amplitude on either solstice is 34 degrees north or south of east and west. Now, find 50% of 34 and put it at the 30-day mark. Find 85% of 34, which is of course 50% plus 35%, and put it at the 60-day mark. Now, compute the number of days from the equinox to the date in question. So what you want to know would be the number of days from February the 11th to March 21st. To make this computation, consider that February normally has 28 days and subtract up to and including today's date, the 11th, and that leaves 17 days in February. Then consider the 21 days in March, and you add the 17 days left in February with the 21 days in March, which means there are a total of 38 days in the time period from February 11th to March 21st. To be consistent and to help eliminate confusion, always work from the equinox, even if it falls at the end and not at the beginning of the season, as it does in this example. In this example, you're 38 days out from the equinox. Estimate where the 38-day point on the line would be and make a mark there. You can now see from your line that your amplitude is going to be somewhere between 17 degrees and 29 degrees, and closer to 17 degrees than to 29 degrees. To get a much closer estimation of your current amplitude, you're going to extrapolate the amplitude change within any partial 30-day period. You are, in this example, 38 days total out from the equinox, meaning after one 30-day period, you'll have only 8 days in the second 30-day period out from the equinox. And in that period, the amplitude change is the difference between 29 degrees and 17 degrees, or 12 degrees. Now, here's how to extrapolate. Take the 8 days in the second 30-day period and divide it by the 30 days in the entire period, and then multiply that by the 12-degree total change in the 30-day period, and you get 3 degrees, which is rounded to the nearest degree. Then add the 17 degrees of amplitude change in the first 30-day period to the 3 degrees of amplitude change in the following 8 days, and you get a current estimated amplitude of 20 degrees. But is it a north or south amplitude? Here's how to know. Amplitude labels from the March to the September equinox are always north, and amplitude labels from the September to the March equinox are always south. The above rules are true no matter which hemisphere you're in. Now, to determine the actual direction, that is the azimuth, of sunrise and sunset, apply these formulas. For north amplitudes, the direction of sunrise equals 90 degrees minus the amplitude, and the direction of sunset equals 270 degrees plus the amplitude. For south amplitudes, the direction of sunrise equals 90 degrees plus the amplitude, and the direction of sunset equals 270 degrees minus the amplitude. Just as a side note here, I've been using the term direction, azimuth, and bearing interchangeably, and those words are pretty much interchangeable. There may be some esoteric difference between azimuth and bearing, for example, but for all practical purposes, those words are interchangeable. So in our example then, since the date is February the 11th, a date which falls between September and March, your amplitude is 20 degrees south, meaning the sun rose today at 20 degrees south of east and set 20 degrees south of west. The direction of sunrise, then, is 110 degrees. That's 90 degrees plus 20 degrees. And the direction of sunset is 250 degrees, which is 270 degrees minus 20 degrees. In another example, let's say the date is November the 11th and the latitude is 10 degrees south. The maximum amplitude at this latitude is 24 degrees. Using our line, let's work it out. Label the left side equinox and the right side solstice. Make a mark at the 50% point and the 85% point. Label the equinox 0 days, the 50% point 30 days, the 85% point 60 days, and the solstice side of the line 90 days. If you have no measuring instrument, you can make these marks simply by eyeballing the line and guessing where they are. The whole point of the line is to create a reasonable graphic representation of what's going on during the season with regard to the sun's amplitude. Next, add the amplitude values for 30 days and 60 days. At 30 days, the amplitude value is 12 degrees because if you take the maximum amplitude value of 24 degrees and multiply it by 50%, there's your 12 degrees. And at 60 days, the amplitude value is 20 degrees because if you take your 24 degree maximum amplitude value and multiply it by 85%, that's your 20 degrees, and I just round to the nearest degree. So now you have your amplitude values filled in. Now compute the number of days you are out from the equinox, meaning you want to know how many days there are from September 21st to November the 11th. You can see this in this example. September has 30 days. We're already at day 21, so that leaves 9 days in September. Add 31 days in October, plus 11 days in November, and we are 51 days out from the equinox. Now, eyeball the line and guess about where the 51-day point is on your line and make a mark there. Your line shows you the amplitude is going to be somewhere between 12 degrees and 20 degrees, and a little bit closer to 20 degrees than to 12 degrees. You are 51 days out from the equinox. During the first 30 days, the amplitude changed 12 degrees. You'll have to extrapolate to determine the change in the remaining 21 days. To do this, take the 21 days in the second 30-day period and divide it by the 30 days in the entire period, and multiply that by the 8 degrees of total amplitude change within that period. You can see that in the second 30-day period, the amplitude went from 12 degrees up to 20 degrees, so there was an 8-degree change. And so 21 divided by 30 times 8 degrees gives you 5.6 degrees, which you just round to 6 degrees. The amplitude then is 12 degrees plus 6 degrees, or 18 degrees. Since the date we're concerned with falls between September and March, the amplitude label is south. Your amplitude then is 18 degrees south, meaning the direction of sunrise is 108 degrees. That's 90 plus 18 degrees, and the direction of sunset is 252 degrees. That's 270 minus 18 degrees. The first time or two this whole deal about computing current amplitude is explained to you, it may seem too complex to use in the field, but it's really not. Just remember that your line represents the season and shows the amplitude changes within that season. Once you know how many days you are out from the equinox, computing your current amplitude is easy. You draw the line simply because it's a graphic representation that helps you keep facts straight without having to remember everything in your head. To use the line, you don't even need pencil and paper. Draw the line with chalk on a flat rock, or with a stick in the dirt. Once you know the amplitude, you essentially know the direction of sunrise and sunset, and that knowledge will prove very useful to you. Let's find out how in the next lecture.